Hi there, for this tutorial we are going to be creating particle effects. And before we get into specific code, let's first talk about the logic behind these particle effects, because it's actually quite simple. What we are effectively going to do is to create a class that has one list, and this list is storing all the individual particles. And then this class has three different methods. One method is to create particles that are going to end up in the list. And all of these particles also have specific attributes. This could be their direction, this could be their size, this could be their lifetime, this could also be their color. Lots of different things that we could do in there. The second method is there to destroy the particles once they reach a certain criteria, like them becoming too small or moving outside of the screen. And lastly, we have an emit method. And this one puts the first two methods together, in the sense that it cycles through the list and moves all the particles and adds the visual effects to them. And that's really all that's needed for the different kind of particle effects. So let's jump right into the code. So here we are in a really basic setup for pygame. And if you don't understand what this means, check out this video and there I explain all of this. But to get started, I'm going to create a new class for our first particle project. And for this one, I'm going to click class and I call this one particle principal. It doesn't need to inherit anything, so we can just go to define and init. And when we initiate this class, all we need is self.particles, and this for now is just going to be an empty list. But basically what we are going to do later on is add particles to this list and then move them and draw around them. And with that covered, we are going to need three more methods, and let me just write them out. The first one is an emit method. Let me just write passive for now. It moves and draws the particles. Then we have another method that is called add particles. And this one is, well, it adds particles. And then we need one more, and that is delete particles. And what this one is doing is it deletes particles after a certain time. And this one is really important, for the simple reason that if we didn't delete our particles after a certain amount of time, we would end up with a crazy amount of elements on our screen and our game would be slowing down. So this method is quite important. But effectively what we are going to do is we always start with this add particles method. And this one adds a particle to our self.particles list. And then emit goes through all of the particles inside of this list and moves them around a tiny bit and then draws them. And while emitting, we also check for certain particles if they get too small, and then we delete them if they are too small. And that way we ensure that we will never have too many particles on the screen at one time. So we have to start with our add particles method. And I do want to call this method all the time, very, very often, so every couple of milliseconds. And to do that, I am going to create a custom event. So I call this one particle event, and this one is pygame.user event +1. So we are effectively creating a user event that we can use in our event loop and trigger this every few milliseconds. So for that, I set a timer with pygame.time.set timer. Then I need our particle event, and then the amount of time in milliseconds I want to pass between each call of the event. In my case, I went with 40, but you could make this longer or shorter depending on what you need. I'll show you once we have our first particle setup ready. But alright, now in the event loop, I want to check if event.type is equal to particle event. And if that is the case, I want to trigger this add particles. So to make that work, I first have to create an object from the class. So let's call this particle1 is equal to particle principal. And then inside of this event, particle1 dot add particles. There we go. So what this basically achieves is that these lines call an event every 40 milliseconds. And then when this event is being called, we are calling this method. So we are adding a particles. So now we have to actually write some code to add particles to it. And really all we have to do is that we are creating a point with an X and the Y position, a direction, and a certain radius. And then later on in the emit method, we are just drawing all of these points and put a circle around them. So, well, really simple actually. But okay, let's get to it. I want to start with creating a X position. And for now, I just put this in the middle of the screen. So I put this at 250. I do the same thing for Y position, and it's also going to be 250. So any particle we are going to create is going to start right in the middle of the screen. Then I want to create a radius, and they're all going to be 10, at least for now. And then I want to create a direction. So I create direction. And for now the direction is just going to be -1. So this would mean all the particles we are creating are just going upwards. And that is effectively it, what we need for our basic particle. Now all I want to do is to create a particle circle. And this one is just, well, it's a list that has another list with position X and position Y. Then we have the radius, and then we have the direction. So really all we're doing in here is adding all of these different variables into one list to make it easier to work with. But we're not creating anything particularly new. And once we have all of that, I get self.particles and append our particle circle. And that's all we needed for the add particles part. So now we can actually look at emitting them. So the first thing I want to check is if there's anything inside of the self.particles, so we have something to animate. And for that, I can just go with self.particles, and any list that has more than one entry is going to evaluate to true. So self.particles, once we have any particle in here, is going to get to true. And if not, we are not doing anything. And then I want to cycle through all of the particles. So for particle in self.particles. So effectively, if there's any particle inside of self.particles, we want to work with all of them. And there are three things I want to do with the particles. Number one is I want to move the particle. Number two is I want to shrink the particle. And number three is I want to actually draw a circle around the particle. So let's work on them step by step. First off, we have to move them. So we have to influence this position X and position Y. So first I'm going to target them. So this is particle 0. And for now I'm just going to move the Y position. So position.Y. And this would be 0 for this entire thing, and then 1 for position Y. And this I want to move in the direction that we created. So this is particle, and this would be 0, 1, and 2. So this is our direction. So +2. So effectively what happens here is that we are taking the Y position and adding -1 or whatever is now a direction to it. So effectively right now we're moving it upwards. Next up is we want to shrink it. So we want to take this radius and make it smaller. So again, I want to go particle and this time 1 for the first element in this list. And this time I want to get minus equal a very small number. And I went with -0.2. But you can experiment around with this quite a bit. Alright, now we're making this radius smaller on every single time this frame here is running. So effectively our circle is going to be smaller. And now all that's left to do is to actually draw all of this. And since I want to draw a circle, I'm going to go with pygame.draw.circle. And now we need a couple of attributes. The first one is on what surface to draw on. In my case, that's easy, the screen. Then we need a color. And I just used the pygame color attributes, and I'm going to make them white. And now for the circle, we need 2 more attributes. First, we need the center position, and then we need the radius. So the radius is actually super simple. That's going to be our particle 1, the one we have created and shrunk in here. Now for our center position, we are going to need an X and the Y position. And fortunately, we have them. This is our position X and position Y. So all we have to do in here is particle 0. And there's one more thing we need to do. When we create a radius around a circle, this has to be an integer. But right now for us, this is going to be a float, because subtracting -0.2 from a number is going to create a float. So we have to put int around here. And there we go. Now in our game loop, I can just call particle1 and call the emit method. And right now, this should be working for a very short amount of time. So let's try. And there we go, we get an error that we are creating a negative radius. So the problem is here that from our radius, we subtract a very small amount all the time. But this radius has to be positive. So after our code runs for about a second, this one is going to get negative and the entire thing crashes. But we can fix that quite easily. And for that, we have our delete particles method. And really, all I want to do in here is that if a particle gets to 0, I want to delete it. But the method how I'm going to achieve this is going to be slightly different. So let me explain. So first, let me get rid of all of this. And the first thing I want to do is I'm going to create a copy of our self.particles. And I called this list particles copy. And now I'm going to use list comprehension. And what I want to do is particle for particle in self.particles. So right now we would take our self.particles list with all the elements inside and just make a one-to-one copy for it. But I don't want to make a one-to-one copy. Instead, what I want to do is only choose the particles that have a radius that is greater than 1. So into this list comprehension, I'm going to add an if statement, and it's going to be if particle 1, so the radius, is greater than 0. So effectively, what we're going to do is we cycle through the entire self.particles list, but only copy particles that have a radius greater than 0. And once we're done with that, we just set our self.particles equal to our particle copy list. And that way, we are going to get rid of all of the particles that are getting to 0. And now again, up here, when I call self.particles, before we're updating all the particles, I want to check self.delete particles. So that before we get into any of this, we delete all the particles that have a radius of smaller than 0. So now let's try the entire thing again. And there we go. We have a very basic particle system. Now, obviously, this doesn't look particularly good, but if we just make some changes, this is going to look much better. The first one is the direction of -1 is a bit too slow. So let's make this to -5. And now let's try again. And this is already looking a bit better, but I think it's moving too fast. So instead of going with particle event 40, so we spawn this every 40 milliseconds, let's go with 150. And now, this is already getting a bit better, but I think now it is moving actually a bit too fast. So let's set this to a lower number. And there we go. This is already looking quite a bit better. So this is really the most basic kind of particle system. If you have gotten this far, you have understood basic particle system. All we have to do now is to make adjustments to this to make it look a bit better. So let's make it look better. So the first thing I want to do is to not spawn this at a specific position, and instead I want to spawn it at our mouse position. So for that, I have to get pygame.mouse.get pos, and this is giving us the x and the y position of our mouse, and from this position, I just want the first one, so the x position. And then same thing for y, but now I want the first one. So now if I run this, now our particles should follow our mouse. And this is already looking quite a bit more interesting. So we are making some pretty good progress. Next up, I want to make the direction a bit more random. And since we need a random number, I have to import the random module. And now for the direction, instead of a fixed number, I want random randint. And this is going from -3 to 3. And now if I run this, this should go into different directions. So now it's going up and down. which is, well, looking quite a bit better, I think. But okay. Now, instead of just moving all of these particles up and down, I want to move them also to the left and to the right. And to do that, I just have to copy this line. So this is the line where we just moved it up and down. And now, instead of just targeting the Y position, we also target the X position. And if I were to run this code right now, we would get, well, a slightly weird effect, but doesn't look too bad actually, but not what I wanted. I want the particles to go in a random direction. But this doesn't work right now because both move in the same direction. So this direction is fixed for both X and Y. And what I need is that this direction has two axes. So I'm going to put it into brackets, and I'm going to have direction X and direction Y. And this is going to be direction X, and this is going to be direction Y. So really now, instead of having one direction with a random number, we have two directions for each axis. And then when we are using the numbers, we want to use 0 and 1. And now let's try this entire thing again. And there we go. Now we have a random particle being emitted from the position of our mouse. And now we can increase the speed again and see how it looks after that. Let's set it to 50. And there we go. Now we have a particle around our mouse that works quite well. So this would be our very basic particle principle. And well, if you've understood this, you could even do all the other parts yourself because they're not fundamentally different. But let's go through them. And the first one is going to be our Nyan Cat. So for the Nyan Cat, we are basically going to follow the same principles, but there are going to be two major differences. The first one is that we don't have one emitter, we have 5 emitters working at the same time. And each of these emitters is going to emit a particle with a different color. And the second difference is that we don't have a circle anymore, we have a rectangle. And I guess there's also a third difference, that we put a Nyan Cat image on the screen, but that doesn't really count because it's super simple. But alright, let's jump right in. So here we are back in our code. And since we are going to reuse a lot of this stuff, I'm just going to copy our entire class and rename it to particle Nyan. And besides that, let me minimize this. I also want to import the image of our Nyan Cat. So for that, I'm going to create a new variable Nyan surface, and this is going to be pygame.image.load, and the image is called nyan_cat.png. And I'm going to add convert alpha to it, so that we convert the image to a better format for pygame, so our code is able to run faster. But alright, now we can actually work on our particles for the Nyan Cat. So we are still going to keep our self.particles. But besides that, I also want a new attribute that I called self.size. And I have set this one to 8. So this is going to be the width and the height of each particle we are going to create. Alright, to emit, we are going to come later. First of all, we are going to work with add particles. And effectively what I'm going to do is I'm going to give it a couple more arguments you can pass into it. And this is going to be an offset and a color. So the offset is going to offset our particle when it's being spawned in the Y direction by a certain amount. So we could have a particle that is a couple of pixels above the mouse screen or below the mouse screen. And the color is the color of the particle. That one, well, it's quite obvious. And now let's go through it. I still want to get the X position of our mouse. So this one stays exactly the same. But for the Y position, I want to add the offset. So this one gets plus offset. So if we don't get the exact mouse position in the Y-axis, we add or subtract something from it. And next up, all of these things can go because we don't need them anymore. And same for this one actually. Because instead, I want to create a particle rectangle. And this one is going to be pygame.rect. So a perfectly normal rect object for pygame. And for this, we need an X position, a Y position, a width, and a height. And these two arguments are super easy because we have defined them up here. So I'm just going to copy self.size and paste them for the width and the height. So this one is the easy part. But now we need to figure out where to spawn them. And here you could be tempted to just type position X and position Y. And this would kind of work, it wouldn't be wrong. But the problem is that a rectangle is always spawned in the top left, but we want to put this on the center. So I have to move it a tiny bit more. And what I want to do is self.size over 2. So that from the top left position, we are moving this thing to the left by half of its size. And thereby we are spawning the center of the point. And then we have to do the exact same thing for the Y position. And now we're good to go. So now we have created a particle rectangle. And this is what I'm going to add to our self.particles. But there's one more thing we need, and that's the color. So instead of just passing in the particle rectangle, I'm going to pass in a tuple with the particle rectangle and the color. And that is basically it, what we needed for this one. And this allows us to call this add particles multiple times and change the offset and the color. And that way we can create multiple particles at the same time. And let's actually do that. So I go further down, back to our particle event. And in here, let me comment out particle 1. And instead what I want to do is, let's go with particle 2, I'm going to name this, dot add particles. And in here, I can set an offset and a color. And let's just start with a really simple one. And let's start with an offset of 0, just to illustrate the principle. And then I want a color, and I'm going to go with pygame.color again, just to keep it simple. And for the color, I am going to go with, let's say red. So this is going to be really similar to the particle one we have created earlier. But obviously we have to create, before I forget, our particle 2 equals particle nyan. And then in our game loop, let's comment out this one. And let's actually call the emit method. It wouldn't work just now, but just to have it ready. Okay, now with all of that stuff covered, we can work on the emit method. And this one is going to stay quite similar, with some notable changes though. So all of this part here stays exactly the same. But now, we don't want to move this thing in a y direction at all. So this line can just go entirely. We also don't want to shrink the particles anymore. So this line can go as well. And now for the X position, we just want to target the actual rectangle. So this particle rect. And I want to move this entire thing by, let's say, 2 pixels to the left on every single frame. And with that covered, all we have to do is to draw the result. And we're still painting on the screen, but now for the color, we are going to go with particle 1. So this is going to be this part here, the color, and then we can get rid of all of this part here and just call particle 0. So again, the particle rect we have created earlier. And now with this, we're almost done. I just realized I made 2 mistakes. This one shouldn't be draw, it should be rect. And for the particle 0, we also want to target the X. So we don't just want to target the particle rect, we want to target the X position of this rectangle. So now all of these lines should be correct. But there's one more thing we have to talk about, and that is this delete particles. Because right now, our delete particles, it looks for particle 1 greater than 0. So right now it looks at this color. But this color could never be smaller than 0, or at least the comparison wouldn't make sense. So we have to do something else. And what I want to do instead is look at our particle rectangle and look at the X position. And only keep the particle if the X is greater than 0. Because if it's smaller than 0, it's going to be outside of the screen. And if that is the case, it's not going to be visible anyway, so we don't have to draw it. So we can get rid of it. And alright, now all of this covered, let's try. And there we go. We're getting a red particle moving to the left. So this is a pretty good start. Now Pygame is going to give me a slightly annoying message that these two should be integers. So let's oblige and let's put integer or int around it to turn them into integers. And now let's try this again, and now we don't get a warning anymore. And there we go. Now we have our red particles. So now we have one particle. All we have to do now is to work with this line here quite a bit, or copy it a couple of times and change the color and the position. So what we can do now is let me put this one to -20. And now it is always going to be slightly above our mouse cursor. And let me actually change this to 100 so we get what this means. So now we can see our mouse cursor is significantly below the particles. And now all we have to do is call this method 6 times for each color. And let me start in the middle. That makes the math the easiest. So I'm going to start with -4, and that is going to be the yellow color. So this one is going to be slightly above the mouse cursor. And then slightly below the mouse cursor, at position 4, we are going to create green particles. Then one layer outside of that, we go to -12. And this one is going to be orange. And then we go to +12 below the cursor. And this one is going to be blue. And then at -20 and +20, we create either a red or a purple particle. And let's try all of this. So now we are getting a rainbow. So that's pretty workable. And here you can see there's a gap between each of these. So let me show this. And this is because the particles don't spawn fast enough or they're moving too fast. You can adjust either of these. I'm going to go with how often we spawn the particles. So let's change this one to 40 and see how that looks. And yeah, it's getting a bit better. There's still some gaps. So let's change the speed of it to -1. And let's try this now. And there we go. This looks much better. There's still some gaps, but for now I'm not going to worry about them. Okay, we are almost done. The last thing we have to do is to draw our cat. So for that, I'm just going to create a new method that I call draw Nyan Cat. Doesn't need any parameters. And all we're going to do in here is to create a rectangle around the cat. So Nyan surface.getRect, and we put the center to where our mouse is. So pygame.mouse.getPos. And once we have that, we just use screen.blit and Nyan surface and Nyan rect. And then in our mid method, I'm just going to call self.draw Nyan Cat, and then we should be good to go. So let's try. And well, it's a bit large, but I guess you get the principle. I think I made the particles a bit too small, so let's work on that really fast. So for the particles, I went with 8 so far. Let's turn it up to 12. And then when we spawn them, this is going to be -6, -18, and -30. And then we get all numbers in positive. So 18 and 30. And now let's try this again. And there we go. This feels much better. And you do have to be aware if I move the cat around randomly on the screen, this kind of breaks. So you do have to be careful about how you use it. But if you only move very slowly, this creates a very nice effect. That looks pretty cool. So, alright, this finishes the Nyan Cat. And for the final one, we are going to create a couple of stars around our mouse. So we're actually going to spawn images instead of just drawing with pygame. And all of this is still going to be incredibly similar compared to the particle we have created in the beginning of this video. But now, instead of drawing circles around each point, we are going to blit an image on this position. But that is basically the entire difference. So let's jump right in and let's see how this works. So here I'm back in my code. And now what I want to do is to copy our original class again. And let me rename it to particle star. And before I do anything else, I am going to create particle 3 and create the actual object from particle star. And then in our particle event, I'm going to call particle 3 dot add particles, and then in our actual game loop, I want to call particle 3 dot emit. So exactly the same for now as we have done with the original particles. But I'm going to make quite a few changes now. So again, let's go through it step by step. I am still going to keep self.particles. But now I'm going to add self.surface, and this is going to be an image of our star. Meaning I have to import an image, so pygame.image.load, and the image is called star.png. And again, I use convert alpha to turn it into a file that Pygame can work easier with. Now we need two more things. The first one is self.width. So we have to know when we create the particles how wide our surface is going to be. So I want to know our self.surface.getRect, and then I want the width. And I want to do the same thing for the height. So just copy the entire thing and change width to height. So now we have the basic attributes that we need to create a couple of particles that are going to be rectangles, and then later on we use those rectangles to blit the surface on each rectangle. Again, I'm going to start working with add particles. And here we still want to get our X position from our mouse position, but again, if we were to just use this position, our mouse would be on the top left of the star, not in the center. So we have to subtract something, and what we have to subtract is self.width divided by 2. And the same for the Y position. So self.height divided by 2. Next up, the radius, we can just get rid of because we're not going to need it anymore. And direction X and direction Y I'm going to keep. And there's one more thing I do want to add, and that's a lifetime. And this one is going to be a rand int between, let's say, 4 and 10. So this is going to be how long our star is going to live. But alright, that's all we needed. All we have to do now is to create a particle rect. And this one again is going to be pygame.rect. And we are going to use position X, position Y, and self.width and self.height. And the particle circle we can just get rid of because we don't need it anymore. And now when we are appending the particle, I want to get our particle rect. I want to get the direction X and the direction Y, and I need the lifetime. And well, that is basically it. So now we can look at the emit method again and make the changes we need to do. And it's not going to be that many actually. So we're going to start with particle.x, and now instead of 1, I'm going to change this to x. And this one is going to be y. So we are targeting this particle rectangle and targeting the x and the y position. And to do that, we have to add either the direction x or the direction y. So this is going to be particle again. For x is going to be 1, and for y it's going to be 2. And then we have to look at the lifetime to kill off the particle at some point. So we have to look at particle 3, and I'm just going to subtract 0.2 again. But you could change this number to whatever you wanted. Just see what feels good. And now this entire line we can get rid of and replace it with screen.blit. Because now we want to blit an image. And what we want to blit is self.surface. And the position we want to get is particle 0. So this particle 0 that we're moving around is just a rectangle, and this rectangle has the same dimensions as our surface. So we can use it to put the surface in the place of the particle, or the rectangle of the particle. And that would basically be it. The last thing we have to do is get our particles again and work with this if condition. And what I want to look for is the lifetime here, so particle 3. And if it's greater than 0, we are going to keep it. And with that, we should be good to go. So let's try. And we are getting an error. That lifetime, this should be random.randint. Now let's try this again. There we go. And we have stars around our mouse screen. Cool. So that's basically it. And again, Python complains about an implicit conversion. So I'm going to put integer around the position when we are going to create our rectangle. So now let's try this again. And there we go. No warnings anymore. And we have our stars that disappear and work perfectly well. So I hope you found this helpful, and I'll see you around.